All right, welcome back everybody to the Ceph Tech Talks. It's been a couple of months since we saw you on Blue Jeans here. Saw a fair amount of folks last month at the April live face-to-face in OpenStack, but before that March was canceled obviously, so welcome back. We're happy to be here. And today's topic is the Ceph Benchmarking Tool. Many of you probably have heard about this, if not participated in it already. This was the effort that's kind of spearheaded by Mark Nelson. A lot of people are taking part in the development and use of CBT. This is starting to be our apples to apples comparison, so everybody can talk Ceph performance and be using the same language at least. This also is going to hook into Ceph Bragg, which many of you have heard me talk about at various places, like the Ceph Day Portland yesterday. But I'm excited to have more CBT usage and to start publishing people's results on the metrics.ceph.com here in the near future. So today, Kyle Bader is going to give us a rundown a bit about CBT and how it works, and we'll go from there. So Kyle, if you could take it away.
Absolutely. Thanks, Patrick. So CBT, Patrick kind of did a brief introduction, but like, what is it? What is this thing? So it's a benchmarking framework. It's written in Python, and it doesn't actually generate load itself. All it is kind of a way of defining test plans through just like a simple YAML configuration. And then it actually, just uses basically parallel SSH to log into the different clients in the system under test to execute different benchmarking tools, right? And I'll go into the different tools that it supports. It's was originally an engineering benchmark tool used for upstream. Mark Nelson wrote it when he was, he was still at Inktank, and we continue to use it in upstream development to kind of analyze the performance trade-offs of different sorts of development efforts. And about a year and a half ago, maybe, we started using it also for downstream performance and sizing work. So one of the responsibilities that I'm tasked with at Red Hat is working with OEMs and ODMs to develop basically Ceph SKUs for different sorts of use cases, right? For different sorts of workloads. And so we would configure different sets of hardware and then use CBT to basically inform how we should reconfigure them and fine tune them to address particular workloads, whether it be object, whether it be block storage. It's used by many people in the Red Hat, in the Ceph community. We use here Red Hat, obviously, like I explained, but it's also heavily used by, the folks over at Intel, Samsung, SanDisk, and then a lot of the OEM, ODM companies that have been working to develop performance and sizing guides with Red Hat. So Quanta, QCT, Supermicro, Dell. So what are the personalities? What are the different nodes that are going to participate in kind of a benchmark with Ceph? The kind of the main, the starting node that kind of coordinates and runs all the benchmarks is referred to as the head node. This is where you're going to have the checkout of the CBT code. It needs to have key-based authentication configured so that it can, SSH into every host. Have the fingerprints of all the clients and the system, all the nodes in the system under test. And it uses PDSH to execute commands, and you just need some space to store the results archives. It can get somewhat big if you're doing a lot of benchmarking, and it's where you're going to have all your YAML test plans that you define out for the sort of benchmarks that you want to run. Obviously, if you're doing some benchmarks, you're going to need to generate loads somewhere in CBT. That's the client personality. So the clients are responsible for generating the load. they'll need to have a Ceph admin keyring because they do some administration level commands like in the case of RBD benchmark, they're going to create the RBDs and maybe map them. So they need to have an admin keyring. This is you could pare down the permissions, but in a lot of types of lab environments, the kind of least privilege is not a huge deal, right? But you could craft keys with specific permissions if you wanted to, I suppose. The CBT doesn't actually install any of the tools that are used to generate loads, so that's something that needs to be installed ahead of time before you start executing the FIO workloads. So whether you're using FIO, whether you're using COSBENCH, you'll want those things installed beforehand. If you're using kind of the KVM RBD FIO benchmark, the client would be the actual VMs that you want to run the workload and not the hypervisor. And they can also be containerized, right? So these could be a list of IPs that point to LXC containers, Docker containers, etc. That's good if you want to do the RBD FIO to test the multiple KRBD instances on a single host. Physical host. And then obviously you have the monitors and the OSDs, just kind of the normal parts of a Ceph cluster. If you are using CBT, if you're using CBT to configure the cluster, this is where it's going to actually set up the monitor quorum and go ahead and provision the OSDs. But that's optional. You can not have CBT do the configuration of the cluster. You can run it against an existing cluster if you'd like. Because maybe you want to configure it in a specific way, or you want to test the cluster as is. Maybe you are installing from, in the case of downstream product, if someone's installing Ceph through the traditional install methods, and they want to know what the performance is of the way that they're actually deploying systems for production. That's where kind of doing benchmarks against an existing cluster is fairly useful. So what benchmarks does it support? Well, there's a number. At the lowest level, there's RADOS bench, and then there's a number of FIO benchmarks depending on what level you want to test RBD. So probably the simplest level is using FIO with the RBD engine, right? That just is FIO running on it can be a bare metal Linux host, it can be a VM, as long as they have access to the Ceph public network. And it just creates a FIO is linked into librd, and it just creates the RBD and writes to it in the actual application. There's no kernel involvement whatsoever. There's FIO for KRBD, and what it'll do is you can run FIO against an ext4 file system on a KRBD device, and then if your clients are actual virtual machines, then it can run FIO against a volume that's been attached to it through normal QEMU mechanisms. And I suppose if you had a different, if you're using different hypervisors, as long as it was pointing to like a VDB device, it would work as well. And then finally, there's COSBENCH if you want to do S3 or Swift testing. COSBENCH is a tool from Intel for testing object storage performance, and it can be used completely independently of CBT, but one of the things you get by running COSBENCH with CBT is you can define the configuration that you want COSBENCH to run in a CBT YAML configuration. So you can kind of pass that between other people that are familiar with CBT, and they'll know exactly what you're talking about without necessarily having to get too familiar with COSBENCH. So what are some of the other things that CBT does that make it kind of great? Like I said before, it can create the cluster. This is something that Mark Nelson does a lot in his upstream work, where he creates multiple or compiles multiple different versions of Ceph, and we use different different sets of binaries and actually create the cluster with them and execute different tests against them to be able to establish, see whether there's performance regressions or see if there's performance improvements for a change in the upstream code. And because of that, it's evolved a couple different functionalities that it can do. It can test cache tier configurations. When we added the cache tier code into the upstream code base in I think Firefly. The CBT was extended to be able to test cache tiering so that we could kind of get an idea of the performance for different sorts of configurations and really analyze how well the cache tiering algorithms were working. Supports replicated erasure coded pools, so you can test both. Obviously, you'll only be able to use erasure coded pools for the object type testing, but it's supported by CBT. And it collects monitoring information on every node during the test, right? So it collects disk, CPU, network, all those sorts of system level metrics from and process information, which is also important from all the machines, both the clients, the OSDs, the monitors, and that way, when you're going back through kind of the results of your testing, you can, if you see performance that is not what you expect, you can see whether there's a bottleneck at disk or at the CPU, and you can use that to inform how you could potentially reconfigure your hardware to eke out more performance. So the basic setup, I hinted at this earlier. You want the want an SSH key on the head node and the public key for the head SSH key on all the hosts, including the head node, because it actually runs some commands on itself. So make sure the public key is in the authorized keys file for all the nodes in the cluster and all the clients. You'll have to pre-install the Ceph packages on the hosts. CBT doesn't, install packages for you. So that's something that is done beforehand. There's kind of a crude setup script that shows some of the stuff that you need to install in the repository if you want to peek into that and see kind of a list of some packages that help out. You want the PDSH packages on all hosts. Not all distributions support these. In most of the Ubuntu or Debian-based distributions, I think it's just available in their regular repositories. If you're running something like CentOS 7 or RHEL 7, you might need to pull in some packages from Fedora, and there's some in the setup script in the CBT repository. There's some links to the which packages you need and where you can get them at. And then you'll need, obviously, to have Collectl installed on the hosts if you want to be collecting monitoring data, which is super useful, so it's highly recommended. So general test methodology, or actually pre-test methodology, really test your network. Bad network can obviously impair the performance of a distributed storage system, and it's remarkably common, especially in kind of quickly assembled lab environments where you're kind of just doing setting up a bunch of machines really quickly to do some tests. So kind of do an all-to-all iPerf where you have every host that are OSDs kind of all running iPerf to all the other hosts, all the other OSDs, both on the public and the cluster network. If you're using a cluster network, make sure to check your routes, your interfaces. For bonding, this is kind of just general Ceph good advice. If you're using bonding, you really want to make sure you're using 5-tuple hashing and LACP. And the nodes themselves should be using like a layer 3+5 transmit hashing policy. And that's because if you don't do that, oftentimes it's going to just hash on the IP or the MAC address of the host or the upstream switch. And that's kind of problematic for unless you have a really, really, really large Ceph cluster with maybe 100 nodes or 1,000 nodes, you're not going to get very balanced distribution across your links. So by using the 5-tuple hashing at the switch and layer 3+5 hashing at the host level, you're going to add entropy to the hashing policy, because it's going to use the port number in the distribution. So it's not just going to rely on the MAC address and the IP address. It's also going to include the port. And since the Ceph messenger is creating connections on different ports to connect to each of the different hosts, you get much better link utilization if you're using a bond. So that's just kind of some general advice, not necessarily specific to CBT. If you're doing kind of micro benchmarks where you're just kind of comparing a few things, obviously you want to do multiple iterations that you can look at the variance between the different runs and kind of establish a standard deviation and understand, maybe you might get an outlier result. So it's good to run multiple iterations. Oftentimes, if you're really wanting to establish the maximum performance of cluster that you have in a lab, you want to do a client sweep, so that you slowly incrementally build load until you kind of hit a point of contention and can see where the max throughput is to the cluster. Because if you just run, if you have 4 clients and all you do is just run 4 clients at a single level of parallelism, you don't know where on the arc of performance you are, and you don't know if that's the maximum performance that you're going to be able to get. So by doing a client sweep, you can see that nice incremental load building on the cluster, and then you'll know that you have established enough client load once you see kind of a point of contention, and you start to get diminishing returns by adding clients. When you're doing these client sweeps, you should always start with 1 client instead of starting at 2 or 4, depending on how many clients you have. By starting at 1, you can measure the efficiency of adding additional clients, right? So if you have 1 host and it's able to do 250 IOPS, and you add in a second host and it does 200, and that one does 240, then the efficiency has gone down a little bit, and so it enables you to see what you want. I mean, in an ideal circumstance, you have linear performance gain as you add clients. Obviously, that's not going to continue on forever as you add clients, but you should always start with a single X1 for a client sweep. And kind of, if you want to be able to establish curve, if you're going to use modeling tools on the data, you should probably have 4 to 6 different increments of clients, right? So you'll do benchmark with 1 client, you'll do a benchmark with 2 clients, you'll do a benchmark with 3 clients, 4, 5, 6, etc. And that way you can you'll have enough points to really be able to do some modeling on the resulting data that you have. And as long as you start to see the drop in efficiency on the higher client counts, you start to see the diminishing returns, and you know that you've pushed enough load against the cluster. So how do you use it, right? So you use, as I mentioned before, you define a test plan for CBT, and that's just a YAML file. So at the top part of your YAML file, you'll kind of have the cluster level configuration, and this would just continue, long form if I had enough space. So I split it in 2, but the pool profiles will just kind of sit underneath the existing, temperature area right there. So you have your cluster configuration where you define your head node. You have an array of the client nodes. You have an array of the OSD nodes and monitor nodes. The OSDs per node, FS, and mount options. I don't know if you're not using the cluster creation, the values for those 3 don't necessarily matter for a while. Even if you're using an existing cluster and you didn't have these set, CBT would bomb out. I don't know if the pull request merged to fix that yet, but so if you're having issues, and you're using an existing cluster, even though you're not creating them, you might need to populate those fields. I'm going to show where the ceph.conf is, the number of iterations that you want to run for the test plan. If you're having CBT build the cluster, whether or not you want to rebuild the cluster between tests, sometimes that's useful. If you want to just have a fresh, clean slate in between runs. And then the temp directory is just where on the head node and the client node they're going to kind of dump the data from the temporary data, the monitoring data, and the output from the various benchmark tools. And then you have the pool profile, where you specify kind of a pool profile. So the higher level replicated, that's kind of the profile name. And then you can specify the number of placement groups you want. Obviously, you want to size that according to your cluster using the general Ceph rules of thumb. And then you can specify a replication level. So that could, instead of saying replicated, it could, which will default to 3. That could be 2 or some other value if you wanted to test a different level of replication. So how do you do client sweeps? I talked a lot about how you want to maybe run with one client and then continue to add more clients. Typically, this is done, or currently, this is done by creating separate test plans and then having a different list of elements in the client's array, right? So if you wanted to run four different client levels for your client sweep, you would create 4 different test plans. The first one you'd have 1 client and 2, and subsequently 3 and 4. And then you can kind of loop through the different test plans that you want to run, and that way you can get data points for different levels of clients. It would be great if we kind of bake this into CBT, but right now this is kind of the way to do it without modifying the code. So benchmarks, kind of the first and most low-level benchmark is obviously RADOS bench. Anyone that's used a bit of Ceph is probably familiar with using it just to kind of establish that the cluster that you just created is working properly. So CBT from the head node, it's going to use PDSH to log into each client, and it's going to spawn a RADOS bench process. You can specify a number of options. You can give an array of different op sizes to iterate through. Whether you want to do just a write-only test or read and write, specify things like the time, number of concurrent operations, whether you want multiple processes per client. Sometimes, obviously, you can increase the number of concurrent ops, which increases the number of threads per RADOS bench process. But that's only, that's limited in terms of its ability to scale up. So if you have really powerful clients, maybe it makes sense to not have as many concurrent ops, but have multiple concurrent processes, each with their own pool of threads. There's the use existing equals true. That's something you would use if you didn't want CBT to create the cluster. And then you can specify the pool profile. If you're having CBT create the cluster, you can have it also set the read aheads. That's not something that's supported right currently for a use existing cluster. We try not to modify the actual behavior of the cluster in terms of changing the configuration with CBT. Whether or not you have to have that set, I think you may have to have that set. I don't know if that's been fixed yet, but the value doesn't matter if you're using an existing cluster. Probably the second most commonly used benchmark is using the librvd FIO benchmark, right? So that's using FIO with the RBD IO engine. So for CBT head node is going to PDSH and all the clients, spawn FIO processes. They're going to use the RBD IO engine. So it's just RBD is linked into librvd, and FIO is linked into librvd. And so it's basically just doing it in user space. There's no No, you don't need to set up any VMs or containers ahead of time. All you need is FIO that's linked to librd. As long as you have, the admin key rating, it'll be able to create the volumes and stress them with FIO. It kind of has the whole gamut, and this isn't an exhaustive list of the things that it can pass to FIO. So if you're accustomed to running FIO at all, a lot of these will look familiar. Volume size, that's the size in megabytes that you want the volume to be created. You can specify the different modes, whether random read, random write. If you want to do a read-write mix, you can specify the percentage of reads that you want. List your op sizes and whether you want multiple processes per volume, multiple volumes per client. Say you have one client and maybe one thing you want to do is run multiple volumes per client. So if you only have 4 nodes, you can still test varying numbers of clients by maybe running one node with 1 volume per client, and then running one node with two volumes per client, and then one node with 3 volumes per client, and then add a second actual client, and then do two client machines with 2 volumes per client, et cetera. And that way you're kind of incrementally increasing the number of volumes, which is relatively equivalent to incrementing the number of clients, as long as you're not hitting a resource bottleneck on your client machines. You can give an array of IO depths. Again, the OSD read ahead, that should be set to something, even if you're using existing and it's not being set. You can provide a path. If you built FIO yourself, you can pass a command path for where the FIO binary should be found. And one thing that's useful is the use existing volume. So you'll have to run one time without the use existing volumes, because the first time you run without use existing volumes, it's going to create the volumes, and CBT preconditions all the volumes, right? So it's going to create the volumes, and then it's going to fill the volumes completely, so that Ceph being thin provisioned, we want to precondition the volumes by filling that RBD device or with random data, so that since this is thin provisioned, it'll actually write out all the objects into the OSDs, and that way it doesn't have to create them as it's running the benchmark, and you have the disk space utilization of the volume size times the number of clients times the number of volumes per client. And if you have a lot of volumes and they're large size, you might not want to be removing these and recreating them for each iteration. So after your initial iteration where you create all your volumes, you might want to add the use existing volumes flag, so you can run a bunch of different tests and use the same set of volumes that you've already preconditioned, and not have to do that repeatedly. There's also FIO to test against KRBD. So CBT is going to PDSH into all the client nodes, create the KRBD volumes, map them to a block device, a RBD block device, and then it'll create an ext4 file system, mount it, and then it'll spawn an FIO process per client, and it'll use the AIO engine to work against files that are created on the file system on KRBD. And this can be a bare metal host, right? If you just want to run a single KRBD, or if you want to run multiple KRBD instances per physical client, you'll probably want to create containers on the physical host, and then list the containers' IP addresses as clients in the clients array, and then each container can then map and create and benchmark its own file system. And so this kind of establishes the performance potential of KRBD, and all the options are very familiar to the other benchmark. And actually, it looks like I have a typo here of benchmarks. The second line there, it says librvdfio. That should be rbdfio. And likewise here, it should be, instead of librvdfio, it should be kvm rbdfio. But finally, the last FIO type test is testing kind of the block performance of KVM QEMU, right? So you'll create the KVM instances beforehand outside of CBT and attach the RBD volumes yourself to the instances, right? So that's not something that CBT does. It doesn't make calls to libvirt or to actually create the KVM instances, right? So the KVM instances that you'll pre-create and attach RBD devices to, you'll list the IPs of the KVM instances as your clients. And then similar to the KRBD benchmark, it's going to create the file system, mount the file system, spawn FIO, execute the workload. And so that way you can establish RBD performance and see how the QEMU IO subsystem interacts with that. And that way you can kind of compare it to the highest performance that's available for librvd if you've done the librvd FIO testing. One kind of quirk that we've seen with testing QEMU, if you have a lot of KVM instances on a hypervisor, and you have FIO running in a lot of these clients on a single host, KVM QEMU is going to emulate the timing call to the hardware registers to get timing information that it uses for accounting for completed IOs. And if you have a lot of machines all running FIO and all requesting timing information, actually the emulation calls sometimes can block the QEMU event loop, and so you can lose the KVM instances can lose ticks. And so when the event loop finally becomes unblocked, then you'll see a large number of completions for all the IOs that completed during the event loop stall, right? So that's kind of a not so great thing about KVM. If you're running a bunch of instances, they can kind of on a single hypervisor, they can kind of lock up due to the really fine timing granularity of FIO, and because QEMU is a event loop between the heavy IO that FIO is pushing in that same event loop and the timing information is collecting in that same loop, you can kind of get stalls. So that's something to be aware of if you all of a sudden see, if you're watching a guest, one of the instances and watching DStat or something, you might see that it misses some ticks, and you'll see a bunch of IO completions right after that, and that's why, right? And then finally, there's COSBENCH. So if you want to exercise the Ceph RGW, you configure the RGW outside of CBT, and you'll install the CBT drivers on both the head node and the clients ahead of time. And basically what the COSBENCH driver does is it translates the CBT YAML to the COSBENCH XML, and then runs the COSBENCH drivers using the command line tools. And in that way, if you're not so familiar with COSBENCH, or if you want to kind of run COSBENCH within CBT, this is a way to do that. And okay, so I've gone through all these YAML test plans and how you can write them out. How do you actually run them? Well, you have your CBT checkout. Say you're doing testing 1 through 6 clients, and you have and you want to test use a bunch of different YAML files. You'll do from the CBT direct, you'll have the CBT directory, then the actual CBT You'll pass it to archive directory to store the results in, and then you'll have the path to test YAML. The test YAML should have a different client. It should have the $ clients and client in there, because that way you're using a different test plan. That's just a typo. So finally, there's analyzing data. There are some kind of crude tools in the repository to kind of analyze the data. Nothing really robust. Kind of what the archive directories look like is a nested directory based on the YAML options. So you'll have the archive directory, whatever you have for the name, the iterations, 0, 0, 0, 0, 0, 0 or 0, 0, 0, 1. And then the type of test, the benchmark that it was running, like librrdfio or RADOS bench, and then it'll have all a different directory for all the different options that you've used. Most of the people that are running CBT right now, at least, are just kind of using a pile of kind of some awk, grep, cut foo. Some people have done some crude work in Python. It'd be great if we kind of all kind of work together to add some really good tools to analyze the data to the CBT repository. That's something that we've always wanted to do. And then, once you have CSV files, you can plot it with whatever your plotting tool of choice, whether, you were using GNU, Plot, Excel, or R. And that's what I have for today. So I think we have some time, so I'd be happy to field any questions.
All right, if you have questions for Kyle, feel free to type them in the chat here, or unmute yourself and ask it in channel. We'll give folks a minute to ask questions here, but if you're dialed in on the phone, if you'd like to ask questions instead in the Ceph IRC channel, you can do that there as well. I will keep an eye out there. All right, I guess there's not a whole lot of questions. You answered them all through your presentation. So thank you very much, Kyle. And people, if you have further questions that you think of later on, let us know in channel. Oh, Bruce would like you to repeat the bonding settings.
Oh, sure. Let me, I'll share the screen again here. So LACP on your switches, you'll want to be using a 5-tuple hash, depending on who your network vendor is. That might be different. The actual commands you use to do that. In Linux, on your Linux nodes, you'll use a LACP or mode 4 bond, and you'll want the XMIT hash policy to be layer 3 plus. That should be layer 3 plus 4. Yeah. I'll provide Patrick with a version that corrects a couple of those typos. We can share that.
All right. Well, we'll get that posted, and this video will also be shared up on the Ceph YouTube channel as well.
Yeah, and also there's a mailing list for CBT. So if anyone has kind of questions that they come up later, or if they start playing with CBT and they're unsure how a particular benchmark works, or just need a little bit of help getting it running, that's what's great about the community. We have a few people using a CBT and following the mailing list. So if you have questions, that's a great forum for them.
Yep. All right. Well, thanks, Kyle, and thank you everybody for coming to the Ceph Tech Talk for May. If you'd like to join us again in June, we'll be back here, the same time, same channel, for on the 23rd. This typically, if there are no scheduling conflicts, it's the fourth Thursday of every month from 1 to 2 p.m. Eastern Standard Time. So we will see you all again next month.